Jai Hind to all. My name is Aarti Chaudhary. I'm assistant professor in AKG College. And today's topic is supervised learning. In supervised learning, we are talking about the machine learning techniques. First one is unsupervised and supervised. What is the difference between supervised and unsupervised learning? What we have having a techniques. So supervised learning is where we have a labeled data and we are categorized according to that. We are training the model according to a labeled data. But on the unsupervised learning, what we are having unlabeled data, and we have to train a model, and then after we are going for a training and testing of that. So in this lecture, I will teaching you two supervised learning techniques, that is a regression and SVM. So what is regression? What is the advantages? What are the types of the regression? What is the disadvantage of regression? Like SVM also. What is the SVM also? Support vector machine also. What are the types of support vector machines? What are the different category? How the data points are classified in the SVM also? What are the regression points also? And all these things we have discussed in breadth about the advantages and disadvantages. And then after, what are the pro and cons of using that supervised learning? So in the regression, what is a regression? How we will need it in day-to-day life. For example, you will go for a prediction. If you want to purchase any home, what are the things you will see as a features, like number of the rooms, size, flat, location. All these are the features of the to make a prediction of it. So what are the features? All these are the independent variables, and for that we will get a feature selection, that all the number of the rooms and all that factors which will affect that convention, and we will get a target of that. Target is the price of the price, that were how much price of this. So all these regression techniques are used for the making a prediction of that, how much we will cost a house, how much which will cost a location according to that dimension. So we are having an independent variable also, independent variable, and we are having a dependent of variable also. Independent variables are all the features, and dependent variables are the what are the targets of it. So the way we will categorize according to that. The way the machine learning techniques used in our application is to be forecasting, predicting the healthcare rates. It is going up and down, and all the house prediction. In this area, this is a posh area, in which they were the 3 BHK makes a crores, and in the other location also we are having a 3 BHK, but it will cost over 50 lakhs. So it depends on location and equality. So all these are forecasting, all depend on the regression. We are getting our past year data. What is a labeled data? Because all these techniques, regression is a supervised learning technique. So we are giving a labeled data, and we will train according to that, and then after we will test the data, that how much cost it will work. All the 24 acres, all the website use this regression techniques according to that. So we are predicting all stock markets also, stock prices also, Nifty and all that. We are making a prediction according to that. Salary changes, portfolio changes, all are the application where the regression is to be used. So all what are the two types of the regression we are using mainly? That is, the first one is the linear regression also. This is a logistic regression, Lasso, Rigo, and polynomial. In the logistic and linear regression, what are the differences? Where we have to use it, where not we have to use it. So in the linear regression, the terms are either we are having a linear relation between an independent and dependent variable. Independent variables are all that which is used to predict the response variables, used to predict that. But dependent variable, which we need to predict it, that number of the we are giving a independent variables, like number of the rooms, size, location. All these things are to be independent variable. And dependent, what are the what is the price, how much it will influence on all that. So all these are things to be. So we are having a dependent variable as an y-axis, and x-axis is an independent variable, and we according to that has to be predict the there was a linear line between the dependent and independent variables. All these are the target values. All these are the target values, and in that target values, what we are influencing that our linear line goes in between to it. All these are the errors which we having we are predicting that, and we are getting errors according to that. So we are having a linear regression in which there is a line between a dependent and independent variable, and this is a slope where we are having a variation between that it will changes, y changes according to x, so there is a slope according to that. And b naught is what the line starts from a y axis. So b naught is a line axis, is have a y predicate also, and this is a slope. B1 is and x is a independent variable, and this is a dependent variable. E is a error. E is a error, like when we have draw between a line between these two, so these points, these dots are the data points. So these data points, how they are accurately measured, that so these are the errors we are having. So we are having a plus minus that of having an error also. For example, we are having using a linear regression. We have to plot the advertisement and sales ka data we are used to predict it. So we are having a advertisement 50, sales 100. So advertisement 50, sales 100. Like 150, we are having a 275. In 200, what we are having a 200, we are having a 300 version. In 250, we are having a 400. So I want to predict that. Okay, this I have these are the data points. In this, we are making a model of it, and then after we are going for a testing. So this is used for the training. These data points are used for training, and then after I have to predict that when we go from 175 advertisement to 175 advertisement, the slope is like this, line ranges, and how much it will cost? It will cost 300. So this is used for making our data. Data is that you are making that prediction according to that data given to it, because we are having a label data according to that. So what are the advantage and disadvantage of using it? It is easy to use because we are having a label data, also clear results, because we were having data. When we are getting label data, we will have a clarity about the result also. Quick calculation also, we will plot a graph, and this is a linear line between independent and dependent variable. Works straight well for the straight lines also, and use for the boundation. But what are the other things? Disadvantage: if we are not having a linear line, it will affect the outliers. Outliers are all the data points which are not accepted as a target points, and they are making a error factors. They are giving a errors, more error to it. So these how can we handle all these things? And it's very complex to handle all these things. We are can't handle a complicated data between the data and data points ke beech mein there was a complexion. Then we can't handle it. Independent, we need to identify what are the independent data, because when we go for any application of it, like forecasting and we have to have a data that has to be labeled, and then after we will give our training according to that. So we have to make a something. We need an independent variable in any of the application which is used by the regression problem. So then we have a logistic regression. This is used for the probability, that is zeros and one, yes or no. All these are probability functions. If will it rain, yes or no, maybe not, but yes or no. We are having two things. Student result, if it pass, fail, that's it. Accidental survival, survived or decision. All these has a probability function, yes or no, true or false, spam or not spam. When we are used to category, this is a famous application that if you want to category that this mail is spam or not spam, and then we are using the logistic regression. So in this, we are having a S-curve. In this S-curve, we are having a maximum of zeros to 1, because probability lies from zeros and 1. So it is become a S-curve, and in that S-curve, if the data points comes above the threshold, it will go to 1. If it is before less than a threshold, it will go to a 0. So automatically that point will go from zeros to 1. Only 0 and 1, not in a between. Threshold say bigger, then it will go to upper side. If it's low, then it will go a lower sides. The logistic function, we are having a same example also. This is a graph of it. If we are having a 0.7 value, it will go up here. If we are having a 0.3 value, it will go down there. The data points are divided according to the threshold value. Upper go up, lower go down. This is a synonym function. In this, we are having a independent variable. Dependent variable, the zeros and one, or all this, we are having a holding value of it. Independent variable, we are having a we are having a response variable. What we are having in this, y is a probability that is used to, this is a y here. This is a y or the probability that happens, which is trying to predict what we have to try to predict. G1 and X1 is the independent variables. In a case, for example, number of house, location, all these are the independence variable that is occur according to that. C is a constant which is used for, which is having a error factor also. That thing also. The use of logistic is that if you want to say that if a person pass or fail, so what we do, it will admission or not admission. So we are having a CGPA as 0 admission 4.2, 0 admission 5.1, 0 admission 1, and it will go for 1 when we are having a value 8.2, 9 or 9.1. All goes in one side. 4.1 because we are having a threshold, and then after it will go in down, then we are having all the value as to be a fail, and this has to be a pass value. Okay, so we are having a three types of logistic functions. We are having logistic regression, that is a binomial when we are having two values, that is yes, no, zeros and when, pass or fails. All these are the types of it. Multinomial, that is we are having a more than three category. When we are having cat, dog, sheep, when three or more categories we are having, then we is a multinomial. Ordinal will we have a three or more possible ordered value, that is high, low, low, high, higher, biggest version. Not satisfactory, very satisfactory. When we are having three or more in a ordered value, in which we are have a unordered value, or in his ordinal we are having a ordered value and three or more value you can use it. So that type of a logistic regression we can use it. What is the advantage and disadvantage? When we are having a logistic regression, it is easy to have a question answer noun, yes or no, zeros or one, handle a curved shape because we are having a S-curve, that is synonym function also. We can have a probability also, we can likely to happen or not. We will give an answer according to that also. It will likely to happen or not happen. Easy to use also because it's easy to understand, because we are having a synonym threshold value upper and threshold value lower will go into a zeros also. It will better to have affect the outliers. So that is a points which is used to handle the error, that it will affect our model. So it will easily happen the outliers also in such matters. But it needs lots of data, because we need a lot of good data to train a model. If it trained good, then we will get a testing of result that conversion metrics, the accuracy up to 90s also. Assume a simple relation between the factors of zeros and ones. There were two choices, not multiple choices we are having into it, zeros or one and yes or no's. Struggling with a complex pattern. If it's not a S pattern, if it's L pattern, other patterns we can't handle all that. Sensitive to a similar variable. If two variables having a similar value, it will problem having that we have to understand to sensitive information. We can't handle it, that similar variables we can't handle it here. So this is a sum up of all the things what we have discussed before, that is the linear regression also and the outline regression also. In the linear regression, there was a continuous dependent variable based on the independent variables also. Continuous, we have a continuous data of occurrence because we have a linear line. According to logistic, we are having a categorical data, yes or no and all that. It will go for a continuous dependent variable. It is a categorical dependent variable. Least square estimation have we are likelihood estimation, zeros and one, likelihood between zeros and ones, straight line, and we are having a curve of S points here. This is a linear relationship between a dependent and independent variable also. Linear relation is not mandatory here, but there is a relation in a linear regression also. Predicting the integer value also, and we are having a binary value, binomial value, 3 or more order or unordered value, in which what is the application of it? See, we are using in business domain or forecasting sales also, classification of the problem, cyber security, and image processing. We are having a logistic regression. So next we will discuss supervised learning is the SVM, that is a support vector machine. In a support vector machine is one of the supervised learning which is used most of the day in the machine learning. It is first introduced in 1960, but laterly it was introduced in the 90s. In this we are having other algorithms, but this is a algorithm which is used to solve the complex problems, use a continuous data also, categorical data also, discrete data also. It used to handle our linear or non-linear classification also. All the data that is used to be here is to be classified according to a SVM algorithm. So this is one of the important algorithm in our machine learning which is using a supervised learning. So we are having a supervised learning in which we are having a data that is we are used to categorize the data by using a hyperplane also. So we will see that if the data is having these are the data points, and this is the data points. So this is the line which is used to distinguish between the two types of data here. And what are the things when we are using a SVM, what are the things which will come into a picture? That is one of the goal is to find the best line which is used to category between the both of them. This is best line. There's no points, green point coming here and no red point is coming there. So this is the best line to differentiate between them. And then what is a hyperplane then? What is a hyperplane? This is a line between we used to divide that. If we want to go for a 2D, there is a line. If we will go for a 3D, there was a flat 3D surface also, and all that dimension also. Then what is a margin? This is a thing which is used to differentiate between two data points, two classes of data points. Then what is a margin? This is a margin that when we are having an extreme point here, green, and this is a red point, these are called a support vector. This is the extreme point between the class 1 or class 2. These are called the support vectors. So these support vectors, they are different. They are how much distance they are from the hyperplane. This is our margin of it. So this is a margin which we are having this is the distance between the closest data point which we are having a support vector to the each of the class to the hyperplane. The support vector are having. So we have to order to find. We can also have a this also. This is also a line. This is also a hyperplane. This is also a hyperplane. This is also a hyperplane, but we have to keep in mind that the maximum margin has to be there. So with that has to be there, that data has to be like this hyperplane is suited most because all the data support vectors has to be maximum distance, and the margin is also maximum, and we are able to distinguish between two of them. So all that things has to keep in flare, and then after you will apply that hyperplane into a picture, and then after the maximum margin has to be there. So we will apply a hit and trial all the hyperplanes into that, and then after we will take a best of all that, okay, it will able to distinguish between. Because the advantage of using SVM is that we are handle a complex data that is not separable, that they are not being separated by a single line also. They are having making a higher, when we use a higher dimension also, they are not able to distinguish between a single line. So we have to flat surface also, any types of dimension. We have complex shapes to make it that they differentiate between that. So that is a advantage of using a SVM in our machine learning techniques we are here. So these what are the types of the SVM we are using here? There was a linear, polynomial, and a Gaussian kernels we are having. All these are we are having a simple linear equations of it, and then after we will calculate according a hyperplane, and then after we will make a kernels of it. So what is a linear? kernel we are in. It is a most basic kernels in using a one dimension, because this is a linear line. What is the application of use is a text classification problem. Text classification, if you want, I have to classify given a text, and then after this is a text related to a SVM or not. So it was what he will do is text classification. According to that, they will classify that this text is related to that topic. Is this text is related to this topic? Otherwise, it is a not related to this topic. What we have given into a question answers. So what is it? It is because it is a faster of all the times we are having a sum of a square f, I, j. All are the data points which is trying to classify all these, having a sum of it, and then after, according to that, how much distance of it we are having it, we will classify according to that on the linear equation. So what we are having a polynomial kernels also. Polynomial kernels, in which it is a generalized polynomial, because polynomial refers to a square, cube, 4, because we are having a degree of it. So in this we are making a dot product into +1 of the power of d, that is any degree 2, 3, 4, 5, all that function. These are the decision points. We have decision boundary to separate between all these classes also. This is less efficient because we are having a polynomial, because more complex and more complicated. In the Gaussian radial, it is a most preferred and used one. It is a choice between, because it is used to, because other two are used for the linear data, but the only one thing is Gaussian is used for non-linear data. So non-linear data we have used to classify it, and we are making up having no proper separation of that. There is no proper knowledge of that. This 9 is this. This line data happens to be here. This time, though proper, no distorted data we are having, non-linear data we are having, and then after we have a category of hyperplane we are having into it. So fj, and we are having exponential. Gamma is a function between zeros and ones, and we are having a making that function has to be that is non-negative, and then there was a square of it. So that has to be more preferred between zeros to 1. So that value is to be, gamma has to be preferred between 0.1 at every time we are having. So what are the linear and non-linear SVM we are having when we are easily classified a data linearly separable data, that is to be classified between a linear SVM, and if that non-linear data that is not easily transferable, we can't transfer having a line, and that easy to differentiate between two datas. So that is a non-linear data we are having. So easily separable by a linear line also, or non-separable by a non-linear line also. We are having complex shapes. According to that, we have to classify it according to that. What are the use cases of using a biometrics by making a protein genes in the genetics also? They are having a classification of SVM. Text categorization, that this mail is spam or not spam. By using that text classification, we will say that this is going to a spam mail, and this is not going to a spam mails also. Image classification also, thus image face is to be recognized as this face is animal, this is cat, this is dog. All these are done by version. Then we have a handwriting recognition. We are identify the letters and deserts in a handwriting, like this is L, this is also L, this is also L, this is L, this is also L, this is also L. All these are things that we use to making that thing. Stock marketing prediction are also used for the historical data thing. So what are the advantage of SVM? Advantage is a well-used features they are using, and in high dimension data also they are using into a high dimension data. Then we can use a small data set with many features also, and we are having a same memory, save memory. We are having more predictions of lots of memory we need to use, because we are using a lots of data into it. Flexible, this is also avoiding overfitting problems also. This is separable between classes and all. They are used to handle the simple or complex data, both linear and non-linear data also. What are the disadvantages using? Not good for the big data sets. We can't handle two big data sets. Messy data set we can't use, that don't work. Hard to pick a right setting, but linear use, polynomial, and Gaussian, which is one was good for us to use this data set use. Difficult to understand because very harder to making a mention. It's require a large data set if you're using a lots of memory we are using. Not good for a given probability. Yes or no, we are not going for a probability. So all these are the things what we have used in a regression. What are the types of regression, linear, logistic, all that advantage and disadvantage, or all these are the thing which we have discussed in SVM. What are the types of SVM, on which data that is good, on which data that is bad. All that thing we have discussed in our slides. So all these are the supervised learning where I have covered two supervised learning, that is SVM and the regression. Okay, thank you.